Hello to everybody who has joined us online. My name is Matthew Cobham and I'm responsible for lighting application at Philips Lighting. And I'd like to welcome you to this Best of Luminous Talks. Luminous Talks is a collaboration now in its second year between Philips and Parsons, the New School for Design. In 2012, we chose the theme Light and Wellbeing. And the aim for this year was to follow on with that, link in with that with the theme Nature and Man-Made. And we will explain more about that shortly. Now, the event part of Luminous Talks took place on the 8th of November at Parsons New School for Design in New York. But it's also important to point out that Luminous Talks is more than just an event. It also involves webinars, publications, and potentially also some collaborative research. So to lead us into this Best of Luminous Talks, I'd like to introduce you to Derek Porter, as well as being an established independent lighting designer based in the United States. He is also director of the lighting design course at Parsons New School for Design. So, I'd like to give a very warm welcome to Derek, who will give a few of his thoughts and words around Luminous Talks and the collaboration between Philips and Parsons. Derek.
Welcome, everyone. First and foremost, I hope that all of you who may have missed the Luminous Talks event on November 8th will visit our live stream channel, where you can view each presentation as well as the introductions and panel discussion in their entirety. Information to access this live stream channel will be included at the end of our webinar today. Today's webinar assembles select snapshots from the live event, with the intent to give you a glimpse into the rich content presented by our four speakers. I might add that the live event includes about 5 hours of recorded footage. Thus, as you can imagine, we've been forced to be quite selective on how we present the so-called best of content to you today. When considering the best way to frame this webinar, we chose to focus on a specific thread of interest as a contextual link throughout the presentation. Our chosen thread adopted a more philosophical underpinning that has to do with the notion of uncertainty. I believe this literal word use may have been presented by Noah Yaffe only. However, the broader association that he infers was at least suggested in all presentations. In Noah's presentation specifically, this notion of uncertainty is affiliated with the non-fixed nature of natural light and the rich experiences its dynamic qualities bring to our built environment and human perception. Noah projects that such immeasurable forces hold extraordinary value in our lives and at times may be forgotten or less recognized amidst the myriad of tangible or measured realities that we all face day to day. However, Noah's comments brought to focus the need to consider and, more specifically, embrace these unknowns as a matter of necessity in the design of our societies. The topic of uncertainty expands to other presenters in a variety of ways that range from the designer's attempt to measure and harness the changing dynamics of nature, to how humans respond biologically to varying forms of light, and finally, an historical survey of electric lighting technology that includes recent solid-state advancements that allow unprecedented approaches to how we consider electric lighting applications and their affiliation to nature and human health. The cumulative outcome of content from these presentations is a recognition that our exposure to light and its impact on our lives is significant. Whether natural or man-made, we have a responsibility to design carefully for its presence and to leave opportunity for the brilliance of uncertain moments. In fact, we should recognize that it's virtually impossible to predict all outcomes of our designs and that we should embrace these unknowns, if not leave room for such rich, undetermined chance opportunities. In order to situate this interest in uncertainty, And to further separate this webinar from the live event, we've chosen to assemble the presentations in reverse order. The live event on November 8th began with the sciences as a means to offer foundational building blocks that started with the measured and led to less measured aspects of light found in design. Here today, we've chosen to begin with the design as a philosophical point of germinating an idea that moves toward a more tangible link to science. Thus, the presentation sequence will start with Noah Yaffe, who will be followed by Davidson Norris, then George Crawford, and will conclude with Raymond Denny. Noah Yaffe is a partner of Stephen Hole Architects, arguably one of the most valuable contemporary architecture firms globally that brings critical and innovative design to our constructive world. Stephen Hall Architects has a particular interest in natural phenomena, multisensorial experience, and the impacts these less tangible effects have on space and human perception. We've edited Noah's presentation to include 2 projects that exhibit variations of scale, conceptual approach, and light relationships. His presentation begins with introducing a couple publications written by Stephen that have had a lasting impression in shaping the firm's design process. As well, they nicely frame our interest today in the topic of uncertainty. Let's now listen to Noah.
I think one of the seminal texts that really forms a foundation of the firm philosophy is anchoring, and I wanted to read just a quick passage from that because I really do feel that that book speaks very, very deeply also to the topic of the day of nature and man-made. So in that, Stephen wrote, "Architecture does not so much intrude on a landscape as it serves to explain it. When a work of architecture successfully fuses a building and a landscape, a third condition emerges. Light, shadow, and shade, its different sources, its opacity, transparency, translucency, and conditions of reflection and refraction intertwine to define or redefine space. Light subjects space to uncertainty." And I did want to talk quite a bit today about the role of uncertainty in this and the role of uncertainty in phenomenological experience and how one can, in fact, embrace that. And then picking up on that was very much picking up on some of the topics we've talked about today. In the book Parallax, one of the other fundamental tenets of the firm's work was established, which is really about the body and space as being the primary, really a primary and essential force of architecture, and really this idea of the enmeshed experience, the multiplicity, the countless viewpoints, perspectives that emerge from being in a space and your body being in that space, and how that can truly shape your understanding. And I'm very curious to hear how Raymond will talk about this after I'm done. But coming from Parallax, from the optic haptic realm of material and detail to the connections of space developed in the light of foreground, middle ground, and distant view, architecture is manifest in perception. Enmeshed experience, or the merging of the object and field, is an elemental force of architecture. One of the fascinating, this was kind of a project that represented a certain sort of extreme idealism to a certain degree. It's kind of a miniature utopia in that it has, it's an intertwining of landscape, art, and architecture in this house. So you have on an upper level, you have and let me see if I will successfully use this or not. So the primary living spaces are this upper level, and then there's a below grade gallery space. And I think the intense division between that is represented in this plane of water. And really this moment, so from when we were previously, this is the front entry, but you really emerge into this kind of miniature utopia through this and emerge up through this plane of water that really, I think, gives you a new definition of a horizontal plane. And within that water, there are skylights that actually bring natural light into the gallery space below, but also are mixed with artificial light to provide the lighting for the site. We design all of our pools to be able to freeze in the winter. We never drain any of our water. So, strange phenomena start to emerge with the light when you embrace these natural things. This is this third condition of the intertwining of a building with the site and the landscape. Unexpected things emerge, like the cracks in the ice that you see here. So further to these lights in the pool, you also see in these living spaces skylights, which also bring natural light, but then are mixed with artificial light. And I think we're very, very conscious in our work. I can't say that there's a singular approach to this. I think you'll see a variety of approaches, but we're very, very conscious of this relationship of natural light and artificial light, sometimes intertwining them as this project, I think, demonstrates quite effectively, but at other times trying to seek a contrast or dialogue between them. I think the idea of embracing diurnal time, seasonal cycles is very much part of our project, and really understanding material properties, but also allowing for the unknown, as you might see, reflections through the leaves, this diaphanous light coming through to create this very delicate reflectivity that's sort of more than the light, more than the material itself, but a merging of the two in a phenomenological condition. In the main living space there, you see that that natural light bringing the skylight, bringing the light into those spaces. One of the more interesting parts of the project is the lower level gallery, and there you see in the first part of that video, the effect of light passing through water and the play of light. When David was talking about dynamic light, just your opportunities to embrace that as a designer are manifold, and new experiences can emerge out of that. And then here you kind of see that dividing line between the lower level and upper level, and the kind of fully enmeshed experience that emerges out of that, and then when you're into the lower gallery level. Shifting scales quite dramatically. This is a project in China. I think one of our work in the last, I would say 7 or 8 years, and a kind of new type of landscape has almost emerged in this space. It's very difficult to describe the feeling of your body in this space. It's, there's the pilotis of Le Corbusier, but this is kind of that, maybe on steroids or something. And below that is a whole dynamic landscape that houses actually a series of auditoriums, other spaces that really make this actually a public space. And I'll talk a little bit in the next project, but I think also the nature of public space in China is a fascinating topic, something for another discussion. Here again, you see different filtering of light, even at this scale where there's still an embracing of the detail and the phenomenological qualities of light. This is a perforated aluminum screen that's south-facing, that's based on sort of a palm frond type of patterning, and you see the material dissolving at the corners of the project, just expressing a kind of indeterminacy and unknown qualities that can emerge in this. Also, I think one of the most fascinating aspects of the project, you can't see it so much here, but is the use of color. And the way that color actually levitates these large masses, and there's a long tradition in Chinese architecture of color up in the ceilings and in temples, and how that's used. And we took many of these same colors, but to get that quality of levitation of this large mass and the contradiction that you can get with this large mass floating, so this horizontal skyscraper floating, and then the unexpected of bodies of water underneath that will cast reflections up into those undersides that were very consciously designed as highly reflective surfaces. So this was an interesting instance. We knew this phenomenon would occur, but how much you try to control that or not try to control that and embrace a certain degree of unknown in that is an interesting part of our work, I think. And then, of course, the inverse, seeing in the water the reflection of the color. And again, the idea of different scales, how you can start to understand this incredibly large building. I mean, it's quite something to be under the Empire State Building laid horizontally, but then breaking that down to the scale of these small pebbles in the water and how that works. I think the idea then at night, how this can be, I think these effects are just augmented to quite significantly, and really, there's, when we talk about the merging of landscape and architecture, the idea then of a spatiality of night creating also just a fascinating condition where your whole understanding of this place, I think, completely changes when you're there at night, and obviously then your experience then in the day is completely transformed by the way you perceive this building at night. So these large pieces of structure, which really, this whole building comes down on 8 cores, and the largest spans in it are 60 meters between the cores. It actually uses bridge suspension technology to achieve those large spans. It's again, another lecture, but something that had never been done before, the combination of a concrete structure and suspension bridges. But then those becoming these light fixtures in the evening at this sort of much larger urban scale, and the type of space that creates, and the levitation you see when you get that light and color mixing, and the power of that reflected in the water, I think, create a completely unique third condition that emerges. So I wanted to talk a little bit about the immeasurable, what Le Corbusier referred to as the ineffable in his work, and phenomenological. These last 2 projects really, I think, speak strongly to that. This is Knud Hamsun Center, which is a museum for the writer Knud Hamsun. It's located in Norway. When we talk about the specificity of a site, it's quite something to build above the Arctic Circle. Here's the project at its opening, which was this amazing celebration. But you see this project sitting in the landscape, and really it becomes a real index of that light and the qualities of light that come through at the different times of year. These cuts that often have sort of strange relationships to the floor plates. Again, kind of enhancing the phenomenological experience of the body. Some of those slides that Raymond showed earlier with the distorted rooms, I feel like we're kind of doing that ourselves. Maybe not for the same effect. But then also surprises that emerge. We have, in this project, there's the main elevator core is a brass spine that travels up through the building, and there's some slight oil canning, some slight bending in the material that occurs. And we knew we'd get reflection off that building, but off that material. But the joy of seeing this at certain time of day, we knew something would happen, but we didn't know this was going to happen, but the embracing of that light, and that phenomenological quality. There you see this low winter light, again, just kind of an amazing quality that you get. And then one of the great joys was after being at that opening in August of 2009. And by the way, in August, when the sun's at sort of at its highest at about 47 degrees, there's a beam of light that cuts its way from the top of the building all the way down to the front entry. But then what was great was the museum director in December, she sent us December 10th, I believe is the date. This was the light at the peak of the sun of that day, and this was the last day they were going to see the sun for a month. But the quality of that horizontal light and the intensity that you get on that white painted concrete surface is quite something. So that was their kind of goodbye to the light.
Davidson Norris is a partner at Carpenter Norris Consulting in New York City, where their work in daylight involves both technical and poetic examinations of natural phenomena, material relationships, and human perception. David's presentation focuses on a single project that attempts to track and redirect sunlight to a small outdoor courtyard in New York City. This space currently has no direct sunlight and only limited sky exposure due to adjacent developments that block the sun. He refers to this overshadowing effect as a black hole, which is unfortunately common within the vast vertical canyons of New York. His response to this absence of light explores how humans perceive the dynamic presence of natural light and attempts to replicate, capture, and redirect this phenomenal presence through a series of static mirrors. The edited footage that you're about to see focuses on only two elements of Davidson's proposed solution. These elements offer diversity of scaled lighting effects. The first includes two different reflector fields that are located on adjacent building facades, which address the scale of the courtyard, as Davidson puts it. The second effect introduces a series of sculptural column-like reflectors that he refers to as sky masks that bring a presence of sky to the scale of the human occupant. Now let's go to Davidson's presentation.
What I am going to show you today is a project that we just got the go-ahead for, and it's at an institution here in New York that I'm not allowed to identify. But it falls into a category that Jamie and I talk about quite frequently that is endemic here in New York, which is the black hole. And we're all familiar with them, and they arise when too small an exterior space is surrounded by buildings that are too dense and too tall. The resulting spaces are ones that are gloomy and dark. And the question then is, what is the solution to the shade that is imparted to that space by these surrounding buildings? And if there is no direct solution, i.e. there's no way to restore enough of the light to make that space once again an easily perceived daylighted space, then are there any other options that at the very minimum can restore a perception of the space as being daylighted? And this is one of our first experiments doing that with fixed reflectors, and I am about to present to you the results, at least of the project so far. You're looking at a courtyard on the Upper East Side. On the south side of the slide, a new building has been erected that is probably 300 feet tall. On the upper right, in the northeast corner, is an existing building probably about 200 feet tall. To the north is a building that is probably 15 stories or 175 feet tall. Smaller buildings to the west, particularly the southwest, and then to the southeast. The result is that this space, given the fact that it previously had a much lower building to the south and therefore reasonably abundant light, now faces the quandary of having very little light whatsoever. So we were asked to take a look at what could be done in order to restore some of the daylight to the space. These are the architect's renderings of the space on the upper left, and then a construction shot taken some months ago on the lower right. And at the very least, the architects didn't kid themselves and provide a light image for the prospective courtyard with the sun blazing in and with lots of bright characteristics typically identified with daylight. I think his portrayal is actually reasonably accurate. But as you can see, it is a space that has very little or no direct sunshine. Another perspective, this one now looking towards the west, and you can see the presence of a raised platform in the mid-distance there, which is one of the architectural focal points of the space. This is a sun mass diagram taken from the center of the courtyard, and as I think it quite vividly proves, there's very little in the way of direct sunlight that ever strikes the center of this courtyard. You can see, however, that there are two windows. If one starts to think of this as a space, there's a window off to the east, shown up there. Hold on. Whoop. There we go. So there's this eastern window here, a larger, in fact, western window over here, and then there is a skylight overhead. So despite the fact that this space is very enclosed, there is the promise of some resources, light resources that we can count on in order to modify the light regime in the courtyard itself. Nonetheless, this gives you some sense of the quality and character of light within the courtyard. So what we were given was the daylighting fact. Tall buildings that surround this courtyard have, as is often the case with New York City courtyards, reduced occupants' access to daylight intensity, variability, and dynamic. The challenge is, how do we then restore richer and more balanced daylight regime in the courtyard, along with the occupants' perception that it is so? This last one, perception that it is so, is critical. It's not a question of trying to bring back the light that used to be. It is a matter of how we can bring back the minimum necessary light to make people believe that there is not abundant, but maybe adequate daylight in the courtyard itself. So we're trying to do this kind of minimalist restoration project of light in the courtyard. Okay, then we looked at how it is that we could integrate reflector fields into the existing building skins. This is brand new space, but it's an existing space. So we did not have an opportunity here to actually design the buildings so that they became themselves these reflectors. And had we been able to do so, it might have been quite a different opportunity. On the other hand, this allowed us to explore the kind of retrofit possibility of this kind of a system where it's applied to existing structures. And that's most often the case here in New York City. It's going to be old buildings, existing courtyards. It's not going to be new construction. So the first set of reflectors we looked at was in the eastern quarter, shown here. And here we realized that what we wanted was one set of reflectors mounted on the south face of this building that then bounced light across to another set of reflectors on the north face of this building, and then eventually put it into the courtyard, where a secondary focus in the morning would be the Ipe platform, the landscape platform. The primary would be the courtyard at the top of the stairs. So what we came up with was a pattern of 5 foot by 5 foot, highly reflective, specular reflective stainless steel panels that got affixed to the spandrel. This is the new building to the south, and they are directly facing across this modest gap. Another set of reflectors, a similar field of reflectors that are mounted on these spandrels. So the light hits these, and bounces into the courtyard. We then took a look at the western side, and here you can see the reflectors now mounted on the top corner of the, or the top near the cornice of the south, or the southwest corner of this residential tower. These ones were primarily directed at providing light to the landscape platform. This red dot is important because that was the target for the reflectors in this field. Here I'm showing a slide of the proposed reflectors, and unlike the reflectors in the eastern side, these ones, as you can see, are tilted and turned. Each one of these is designed, and starting up here in January, running down here till June, this going from about 12:30 to about 6:30. Each of these on about a 20-minute cycle is designed to put the light at that target point during that time on the month. This is the matrix where we had column A through J here. We had row 12 through 6 here, and it goes from December to June and then back up again. And each one of these at a given time, so at 2:40 p.m. on June 21st, this reflector right here is targeted to provide light at that target point. Then we evaluated the added reflective light with respect to its occupant perception, location, timing, and distribution. This is a series of radiance images that we produced. Over here you can see the landscaped platform. Over here, the top of the stairs with the secondary target, the eastern target, at the eastern end of the courtyard. And what this will show is the light that is projected into the courtyard by means of the eastern reflectors during the morning and the western reflectors during the afternoon. So here you can see, and it starts at about 8 o'clock and it'll run through about 6 o'clock. And I'll just run through them one at a time. Bright light coming in through that window, even brighter. But you can also see some of the additional light being reflected from reflectors that are now on this face of the south-facing tower. You can see now these are the remnants of the reflected light from the south-facing tower. These ones are actually being directly reflected onto this, which is actually a hops wall, a landscaped wall. Now you can see the full deployment from the south-facing reflector field. Moves across. It's about to intersect with the north-facing field. And you can see these patterns in here are all double reflections. Hits here, bounces into the courtyard. Whoops, I'm going the wrong way. Sorry. Now it swings around to the west reflector field, and remember, the west reflector field is much more targeted. Observe down here, that's the target point. And what you'll see is a series of these move through the target point. Whoops, I'm sorry, I'm going back again. Now you can see over here, remember this is landscape. There are trees in there. And so those patches of sunlight, as they stream down and hit those trees, they will cast shadows, they will penetrate through the canopy of those trees, and they will start to create incidences, light space incidences that are common to us all and perceptible to us all, and that will be part of, hopefully, that shift in perception. Then as it moves on through the afternoon, you can see this migration of this school of light patches towards the east, and moves up and onto the north face of the building, keeps moving, and disappears. So I think this too gave us a good deal of confidence that we could deliver the light, and we could make it very, comparatively speaking, very animated, and it did in fact target these two basic zones that we had designated. The next thing was to, okay, if that's what we had to do in order to harvest the light and redirect it to these places, then we felt that what we had to do is provide secondary targets that actually allowed you to perceive it much more readily. So what we came up with is essentially the same idea of the ribbon, but now the ribbon, instead of it being the 3 ribbons facing south, in fact, there's 12 ribbons that fully encircle these columns that are then embedded in the landscape on the landscaped platform. This gives you some sense of now what happens. These aren't just trees, but these thicker ones, in fact, are these light masts, sky masts we call them, and they too will receive the light, and then given the fact that they're highly reflective, they will suddenly bring brilliance directly to your eye, which will capture your attention. The other part of it that was critical is that we're not just talking about redirected sunlight, but we are talking about skylight as well. And in all of our projects, it's not just about getting the light in an absolutely equal priority. It's about getting the eye out. And so these reflector masks are not only designed so that if the reflected light from the fields hits a part of the ribbon here, it will reflect it down. But if you were standing here at 40 feet away and you look at the mast, that there is a part of the ribbon that is tilted so that it shoots your eye directly up. So what you are looking at when you're looking at the mast is the sky, right? So all of a sudden that sky that seems so distant, and you're at the bottom of this well, and is now something that is brought into your perception. And sometimes it's all you see is the sky. At other times you're going to see it along with the reflected beam of sunlight from the reflector fields. This shows a quick slide showing how we actually go ahead and we determine what those angles are. They are different depending on how that particular ribbon is oriented in the space. And so here gives you a sense of this would be the primary reflector for the sky. These are primary reflectors, and so it comes down, out. This is coming from a lower angle. These reflectors take the intersecting light from the reflector fields and brings that to your eye. The next target that we looked at was used the same technology, i.e. The ribbons, but now it focused the ribbons instead of out in the open and integrated in amongst the trees, such as with the sky masts. The sky ribbons, in fact, were integrated in a hops wall that was against the south side of the raised platform. And hops grows very fast. It's very dense. And the idea was that we would insert the ribbons in exactly the same plane as the growth of vegetation, so that during the winter and the hops dies, it would simply be this orderly succession of these sky ribbons. But during the summer when the hops grows, the hope is, in fact the conviction is, that the leaves will actually integrate with the sky ribbons as well. The result is, we hope, that it will be like looking into this forest that is kind of collapsed. Out on the platform, what we have are these sky masts that are in amongst the trees. And sometimes you see them singly and alone, and other times you see them through the trees. This takes that imagery basically and collapses it into a single plane. I think the one that I'm most curious about is what happens when the hops grows out and into the reflector system. And at that point, I think people will look at it and they'll say, where is that light coming from? Am I seeing all the way through the building? And it's those times where I think we're going to be able to capture not only their eye, but their imagination.
Okay, so let's continue now with our third speaker, George Crappard. George is Fellow of LED Research at Philips Luminous. He can be accurately described as being one of the godfathers of LED technology, as along with others, he took a pivotal role in developing LED technology in the very early days. And in fact, his career spans back more than 50 years, so he really is one of the originators of LED as we know it today. So, of course, we're going to hear, as with the first two speakers, just a very kind of short section of the talk, which actually lasted around 40 minutes. So to help you make sense of all of the elements he's going to talk about, let me just give you a little summary. We will start with a little bit of history, then look at how efficiency in LED sources has developed. We will then make the point that right at the beginning, and even up until quite recently, there was a lot of disbelief that LED would become a major light source, and really now, of course, the leading light source. We'll then look a little bit at the performance of LED compared with other light sources, and then George spent a little bit of time talking about kind of one of the key research fields in LED around the green part of the spectrum and trying to fill that gap, which is a challenge in LED research. He then gave a very kind of short course in LED technology before moving into talking about different color measurement systems, which again is one of the key areas in LED development, of course, as in any light source development. And then his talk really concludes with talking about the evolution of the technology and linking that with design, architectural design and design in a broader sense. And then he gave some concluding thoughts. So let's listen to George Crappard.
Okay, today I'm going to lead you through these topics. I'm going to talk a little about the history of LEDs, and well, first the early history of lighting, and then move to the LEDs. And I'll talk a little about the quality of light, recent trends, and speculate a little bit about what the future will bring in LED technology. So 30 years later now, this is 1909, they had tungsten filaments, and that was the big thing, to go from carbon filaments to tungsten filaments. Then light bulbs lasted a long time, and there was the difference between these two is this one is a drawn tungsten, so it's a fine tungsten wire. So after 30 years of work, they had a light bulb that's pretty much the way electric light bulbs are today. Okay, now we switch to a timeline of lighting history that shows on the left the early lamps of various types, working way up to the incandescents listed after 1900. And the incandescents, once that was around, didn't change a lot. It was pretty much flat. You had the other types of lighting coming up, fluorescence, much more efficient, and this is efficiency in percent. And then you see LEDs here in this region, shown here from around 1960 on, going up in the red and the blue later. And now what I'm going to do is kind of zoom in on the LED part of that figure. And this is a picture of Holonyak at the University of Illinois. He started at General Electric, as I mentioned, and the management at the time wanted him to switch from working on LEDs to work on silicon electronics, because they thought that was going to be important, which of course it was. But he wanted to work on LEDs, so he went to Illinois, which was a great thing for me because I became one of his first students at the University of Illinois. He just retired this fall. And this was a very controversial ad. And in fact, I was giving a talk at a at a conference after this ad came out, and a high-level manager at a very important and influential laboratory not too far from here across the river accosted me basically publicly and said, "Oh, you are from Monsanto. That's the company that has that ad in the Wall Street Journal. Don't you know that it is technically incompetent to even suggest that LEDs will ever be used for automobile headlights?" So this picture was taken at the 50th anniversary of the LED. And by the way, Holonyak was somewhat abused by this whole idea because he was a consultant at Monsanto. And I presented him, we had this covered up with a black cloth, presented him with an automobile headlight completely made with LEDs. And this work was done, that was actually work that started in the 60s at RCA. And then in Japan, there was a man named Akasaki that kept the work going. And finally in the 90s, Nakamura, who's a very famous researcher at Nichia, and now he's at Santa Barbara, developed high brightness blues. Blue is important because you use a blue LED to make white. You start with blue, you put phosphor on it, and that's how you make white. So that was a key missing link. One of the research areas in LEDs is trying to figure out how to fill this green gap, how to make a better green. Because if you wanted to use, because LEDs without phosphors can be more efficient. Whenever you put a phosphor on an LED, you inherently lose efficiency because you're down converting blue light to other colors. So the most efficient source would be a mixture of pure LEDs. I'm going to give you a very, very short course in LED technology here. Oh, that came out differently too. But at any rate, these are the 4 key elements. Our epitaxy materials, that's the semiconductor material itself. The device chip, that's how you make the layers and how you attach the thing. The phosphor you put on it, and the package. And these 4 elements all can be improved. And what's going to happen over the next years is each one of these is basically going to be improved some, and overall we're going to get a factor of 2x improvement in LEDs. There are other systems that have been proposed. There's a CQS system, which I think is better, that NIST has proposed. There are 2 or 3 other systems that have been proposed. But they really, this CRI is the one that's here, it's the one we've got, it's the one people use. And all I would say is, and LEDs can work very well with the CRI system. One of the problems with the CRI system is you can game it. You can tune your light source so it matches these color tiles in a particular way and get a higher CRI reading. Then if you just tweak it a little bit the other way, you get a low CRI reading. It doesn't really make it much difference in terms of using it to actually look at something. So you just have to, I would say, be skeptical of the CRI thing, but it is the best we have, and LEDs can certainly make CRIs of over 90. People hope that there'll be a new system, but I don't think it'll happen. My impression is it's not going to happen anytime soon. Okay, so what kind of spectra are we talking about? Daylight is shown up on the left. Incandescent bulbs, nice smooth light. Fluorescent, very spiky. And the fluorescent tubes were often designed, the phosphors are chosen basically to game the CRI system to get the highest CRIs they could get for a fluorescent tube. Halogen shown over there. And you have both a cool white and a warm white LED. Cool white has a bigger blue spike. Warm white has a smaller blue spike. And there's a hump here where you've added red phosphor to it. So with an LED, you can tune this system. It's not like an incandescent that you drive the current through it and you get a certain, with an LED you can decide which phosphors you want to add to get, you know, what kind of color you want to get. And people do specifically tune it. Some people tune it so it doesn't maybe try and match one of these natural spectrum, but it makes certain colors pop out. And so for retailers, for example, they like something that maybe has more blue or UV because it makes the white pop out of a shirt. So you can play games in favor of enhancing certain colors if you want to do it. But just to show kind of the vagaries of the CIE thing, down here at the bottom, if you narrow that spectrum, and if you have two different red phosphors, one that peaks at 620 and one that peaks at 615, not much change. As you can see, the spectra are pretty similar. But the color rendering goes from 90 to 80 with just that tiny little shift, just because it's the way it works with the tile. So you have to take all this with a grain of salt. So this whole system is a little complicated, but the message is LEDs can give you very nice color rendering index. They can give you very good quality of light as measured with many tests with different kinds of samples. It just, I think the user has to just be aware of that and evaluate the sources. Complicated. Before one of these, I was talking to a government group years ago about this issue, and there's a lot of mathematics involved in it, and it was complicated. And to get some clarity, I asked my 6-year-old granddaughter, what is white? Oh, that slide's coming up. Sorry, I got one slide left out. The other approach beside the phosphor is using individual LEDs to tune it, the narrow line spectrum. And this shows 3 lines, red, green, blue. You can also use a 4th one, red, green, blue, yellow. And you can make a very efficient source, as I mentioned earlier, and you can get very high CRI. And there's a group of people that believe this will be the future of LED technology, is having high efficiency red, green, blue, yellow narrow sources. Could be. Completely tunable. But they are narrow sources. And I guess I'm personally not so sure that's going to make people happy, even if it, even if it has a high CRI and a high efficiency. To really sort out the difference between color tiles, if you illuminate it with a light, there have been tests that show you need a broadband phosphor in there too. So I kind of expect that'll be needed. But anyhow, as I say, this was complicated. I asked my granddaughter, and this was her answer as to what white is. And I have to tell you, when I get tangled up in discussions like this, I think of this as I really know what white is in spite of all these different. Okay, now talk about just there's a kind of an existence of a situation where if you change a technology, the new technology often ends up looking a lot like the older technology because that's what you're familiar with. There are certain practical constraints as to what you want to do with the technology, but you find that you went from a horse-drawn buggy to a car and they look kind of the same. You could almost put somebody up there with reins on this one. And of course that's happened with the light bulb. You have the incandescent bulb going to some version of a very similar looking light bulb. Well, why is that? Well, you have the Edison sockets. You have those sockets around that I mentioned earlier that don't conduct away heat, so you have lots of sockets. You have to put something in them. And that's similar with fluorescent tubes, too. But as time goes on, you can ask the question, as a designer, you can ask, well, what if you didn't go through this phase? What if Edison and Swan and those guys hadn't made that kind of A lamp? Would LEDs have this kind of form factor? And the answer is no, never would do that. This is force-fitting LEDs into a shape that was designed for another technology. In fact, it seemed to me that you tended to have the European, Italian, and quite a few Europeans were more interested in the lighting, more interested in coming up with something different than many of the U.S. people. So I'm hoping with design school like this, it'll change. Something that's historical and I expect will project into the future is light usage has been going up on a log scale here as the cost of light comes down. And this has been going on since you were dealing with candles up through fluorescence, and now as you go up to LEDs, you're going to get, I expect, more and more light being used. It's kind of an elephant in the room in the sense we talk about saving energy, but we think of more and more uses for them. We're lighting the outside of buildings now, not just the inside. But anyhow, there's going to be more and more and more light used and opportunities for designers to come up with new applications. So in conclusion, technology is clearly ready for prime time, adoption's well underway, cost reduction's a key thing is happening, plenty of design opportunities, and it will save 50 nuclear power plants just in the US if you do it, and I don't know if this thing will work. When you see the world at night, all that is waste light. That isn't doing anybody any good, it's just out in space. When you go to LEDs, you can design them so that the light goes where you want it much more efficiently. And so you can expect the bright regions of the world at night to become somewhat dimmer. And there's also a lot of the globe that is dark that you can expect to get brighter, because this interaction of solar cells and LEDs was actually on the last slide. There was an example of home lighting where they used LEDs with solar cells to extend the day. You'll see more of that happening. That's off-grid. You're seeing that a lot now in off-grid countries where you're having lighting in places that they didn't have lighting to lengthen the day before. So you're going to see some of the darker areas get brighter and more uniform, and some of the brighter areas get dimmer, and hopefully, and I'm sure we will have a vastly changed world than we have today. Thank you.
So let's now come to the final speaker in this best of Luminous Talks, neuroscientist Professor Raymond Van E. As well as being a senior research scientist at Philips Research, he is chair of Centre Neuroscience at the Radboud University in Nijmegen in the Netherlands, and also chair of visual perception at the University of Leuven. In the last years, Raymond's work has focused on how the brain reacts to stimuli in artificial space. So let me give you kind of a little summary of his talk, which will then hopefully also make better sense of, again, the 10 minutes of his around 45 minute talk. So Raymond will start here in this Best of Luminous Talks with how the brain is influenced by stimuli and how attention is grabbed. And then he really makes the point that it's essential for designers to think multi-sensory, to think about all the senses that come together in one place at one time, and how together what that then means for design and then influence on people's perception of space. He then talks a little bit about brain activity, some fascinating sections that talk all about how the brain works and how attention is grabbed. Again, then goes some sort of images of the brain and activity in the brain, and then kind of illustrated how some of these things work with different illusions and how people can be influenced. And then made the point about how all of that influence comes about is also determined a lot by expectation. So from a design perspective, that is also critical to build up the right level of expectation in the right places for the design to make sense for people. And then he gave a sort of short summary of current research into kind of predicting actually choices that people will actually make. So literally kind of reading the mind. And of course this can have all sorts of influences on design. Then we kind of really moved into application, and Raymond completed his talk by looking at this all in practice, particularly taking retail as an example, and looking how you can use light, also combined with other stimuli, to help shoppers actually choose different products and move around different parts of the store as an example. So that just gives you an idea of what Raymond's going to talk about. So let's listen to what Raymond's got to say.
Thank you, Matthew and Derek. It's fantastic to be here, and I'm sure I will learn a lot from the next speakers. And I hope you will learn a lot as well. So, LED technology. Those recent advancements in light technology have now opened up huge possibilities for new applications. And I will give you a neuroscience view today. I've been asked to particularly capitalize on academic insights on what you as designers can learn on how to optimally use and influence the human brain, and to make the people that enter your designed places really take what you want them to take away. Let me concentrate on the main factors. So we have on the bottom here optimal behavior, that's the goal. We have visual stimulation, that's our tool. And we have in the top here dynamic light, what we will use, and of course the brain. Now, in preparing this talk, I thought, what's particularly interesting for designers to hear today? Of course, there are multiple possibilities that I can, multiple ways in which I can present possibilities, but I thought I'd take two. One of them is how to grab the attention of your audience in your spaces optimally. And the other one is how do we do that, taking account the body clock, the pacemaker in the brain that's entrained by light. We don't want to design lighting patterns that disrupt this pacemaker. So that's important. And particularly using disrupted light patterns and disrupting the pacemaker, we can go into all kind of even psychiatric symptoms, and we don't want to do that. And I would like to tell you something about that. The take-home message for today is, I already prime you on what I hope you will learn, is first, designers, it's now time to think multisensory. In addition to all the light that we use, we can also add other perceptual modalities. And I will show you how you can do that optimally. And the other take-home message is use the light that you present, design it such that you don't disrupt the circadian pacemaker clock. And what we see here is a computer rendering of real brain activity of this person looking at this picture, this complex picture of three balls with different contrasts and even reflections. And what's interesting is that only little information makes it to the frontal brain. You see most of the brain activity is actually in the visual cortex, in the backside of the brain, and not so much of this information makes it to the frontal brain, where attentional processes are guided. Well, attention then. All day long we are bombarded by all kinds of signals and thoughts. And it's really through our attentional system that we are able to select this information that we want to, be aware of. Only those neurons that are subjected to a contrast difference will be active. Same for stationary objects. If an object moves and comes suddenly in your visual field, then there is an, of course it makes it to awareness. But if an object is just stationary, you won't process it. You won't feel your clothes all day long, unless somebody touches you. Why would you want to feel your shirt all day long? Nothing changes, not important. And you already filter that information out at the gate. And well, the first modality I will use is magnetic resonance imaging. And the F is functional magnetic resonance imaging, and that works by detecting the oxygen in the blood. So when you see a face, the face area lights up, and this lighting up means that the face area in your brain, the face perception, needs oxygen. More blood is going to that area, and that's what we measure. Those are modalities that I will use in showing you brain activity. And the first question that we must ask ourselves is, well, to study attention, what is an optimal visual stimulus? What we actually need is fixed visual stimulation and changing activity or changing attention in the brain. If we want to study attention, it's not so practical to use changing images, because of course then we see all kinds of brain activity changing all the time. What we need is fixed stimulation and changing brain activity. But before I do that, I want to show you two astonishing 3D illusions. And I want to show you that because you as designers, well, may like to know that we have built-in hardware interpretations of some objects that, and it's hard to allow the brain not to, or to see the real depth. And this is one. This is the Holo mask illusion. What we look at now is a mask, and we look at the convex side. But there's also a concave side on the other side. But we won't see that. I now start rotating it. So it's convex, convex, convex. Now it's concave, but your brain makes it convex. Look, here it's funny, and now it's okay. Convex, convex. Now you must see a concave, but you don't. And now it's funny because the other side comes in front. And here we see that even although we want to see it concave, your brain simply doesn't allow you to do that.
So our perception of the world is affected as much by what our brains expect to see as what is actually in front of us. This room looks normal, but in fact it's massively distorted. The girls are exactly the same size, and yet your brain won't allow you to see them that way. You can't tell that the left side of the room is much bigger than the right side, or that the floor slopes down to the left corner.
You see the girl getting bigger?
The furniture has been specially designed.
That's because she comes closer.
All this creates the illusion that the girl is changing size as she walks across the room.
Okay, point made. And what you see here is that we change the depth of the necker cube, and this quantitative relationship comes back in this area, so that we now can quantitatively measure which of the two percepts you saw, and in the same area, this one, this activity for the other interpretation goes down. And we can go as far that we can do mind reading. So even before you press a button, I see left side in front, or I see right side in front, we as experimenters can already know 40 milliseconds earlier than you press that button, because your motor cortex and your arm movement takes that long. We already know what you are going to answer. And well, that finding had quite some impact. And Gijs Brouwer was invited to make this cover of the Journal of Neuroscience. And it's nice, because this is actually my brain in a 3D computer rendering. And so it's, well, I didn't make it to the cover, but my brain did. And now is the question, well, who am I? Am I my brain, or who made it to the cover? Well, let's say Gijs did. Now, how to enhance attentional control? And my approach is multimodal. You remember one of my take-home messages for you will be, try to think multimodal, not only in visual stimulation, but try to use, for example, sound as well. And that's what I'm going to do here. Well, we first need to know about a model for how the brain controls attention. What we see here is a slice of the brain, two eyes. It's a horizontal slice. And here the backside. And visual cortex in the backside here is systematically drawn by a box. And there is the auditory cortex also systematically drawn by a box. It's not exactly here, but, well, this is science, eh? And they all strive for attention. So they all want to be focused on. Well, it's the parietal cortex that integrates all the information, which is connected to the limbic system, and that gives a kind of a validation or emotion to those incoming signals. That's using multimodal attention is actually what gave rise to a couple of inventions, and that made me go to Philips research only a couple of years ago. Before that, I was a happy university teacher. And I won't go through all the details. What is important for you is that if two signals change over time in a similar fashion, here we see that, take a looming signal, that in the vision, the brightness changes over time, it gets brighter and less bright and brighter. And if at the same time the auditory signal is changing with the same rhythm, then that's an important signal. Then we say if the peaks are at the same moment, if they have the same period, same frequency, then they are rhythmically synchronous. And those signals are very important for your brain and overrule other attentional distractions. Imagine that you are in the jungle millions of years ago and something is coming at you, getting bigger and louder. Well, it may save your life if you are not thinking of well, I still need to do shopping, or I need to do my car washing, or have that exam tomorrow. And this is an example where we try this out. This is a mock-up supermarket built in our research facility, and I was particularly interested in dynamic packaging. What we have here is packaging that changes in brightness over time. And one of the questions we ask is, will this grab your attention quicker? This is a computer rendering of the supermarket, but the experiments were done really in the supermarket, not on a computer monitor. And what you see here is a cart and a stool with the observer, the subject, fixating at a point a few meters away. And then what we did in this scientific experiment is we presented on the left side, about 45 degrees over there, and on the other side, 45 degrees, we presented visual and auditory stimuli. And all the subject had to answer. I find the left one more attractive and it grabs more attention. So 2 questions for each stimulation. And after that answer, the next one came up. And we did that hundreds of times with many different combinations. And each time the subject responded, well, I find the left side more attractive. And although it's more attractive, it doesn't grab my attention so much. So for attention, I go for the right side. So that decision hundreds of times. And this is the data. And there was also sound. So let me show that for you. This is a typical sound that went synchronously with the dynamic packaging. And particularly for green tea or shower products or mental health products, this was a nice stimulus. 1 minute, let me wrap up then. I started with the recent LED technology advancements, which opened so many new approaches to design. Then we went to neuroscience, brain imaging, and we found one conclusion that multisensory synchronous stimulation helps to grab attention. And that's one of the take-home messages, that we may want to go beyond only light presentation, but also use other perceptual modalities. Well, then we went to the nature and man-made differences, which can have lasting effects on us individually, namely our shifted circadian clock. And for the future, you may want to take into consideration that there are critical physiological aspects to the design.
So that concludes the best of Luminous Talks in terms of giving you an idea of what our 4 speakers at Luminous Talks, which took place at the Parsons School of Design on the 8th of November, what they actually covered. And really what I want to do now is just sort of link in with what we're planning and it gives you a little bit of a taste of that. The intention now is to really take this forward, and for Luminous Talks to continue to be an annual event. And so we will keep you updated on what is actually being planned. And I would now like to hand back to Derek Porter, who's going to give kind of some of his concluding words. And from my side, Matthew Cobham, I hope you've found this useful. And of course, if you've got any comments, then please participate in our LinkedIn group. The address for that will appear at the end, and then we really hope that we can continue this dialogue. So, Derek.
Thank you, Matthew. And I might begin my concluding remarks by simply expanding upon a couple of things that you touched on. We've attempted to structure Luminous Talks as an event in the lighting industry that is unique from others. By focusing on a single topic, we're able to achieve a deeper inquiry from a variety of perspectives via our presenters that frame subsequently an opportunity for collective debate and discussion. We hope that all of you have found the first two Luminous Talks events to be rewarding, and we certainly welcome your feedback. As well, we are in the planning stages for Luminous Talks 3, which we imagine to launch in New York City next fall. And we request that you check our website periodically for new posts and updates with its evolution. The live streaming details for Luminous Talks 2, if you haven't seen them and wish to visit those presentations, are available on your screen currently. And in conclusion, I'd simply like to thank Philips for the very enjoyable collaboration over the last 2 years, and Parsons certainly looks forward to the continued relationship in the future.